So in this example, we're going to look at integrating even powers of sine and cosine. And there's a different methodology here than if you're doing odd powers of sine and cosine. So when you're going through this, you have to have these essential relationships. You get these in the maths papers. But basically, the cosine of 2x is equal to 1 minus 2 sine squared x. That you'll find that in the mathematical tables. You'll also find this rule. So when you have a power like this, sine squared, your objective is to split it into single terms without any power. So if it's a sine function to be squared, you say it's equal to half times 1 minus cosine 2x. And if it's cosine squared, you say it's a half times 1 plus cosine 2x. So these are the two rules that you need to use, these two here. So if I do it a bit neater, that's rule number 1. So if it's sine squared, rule number 2, if it's cosine squared, and also you need this rule that the square of a cosine squared x plus sine squared x adds up to 1. So if we look at this example here, sine squared x. Sine squared x, using our rule here, using our rule up here, is equal to half times 1 minus cosine 2x. So I take the half outside. And then we have two integrals here. It's 1 minus cosine 2x. So we just have two integrals here. The integral of dx, which is the 1, basically, 1 times dx, and the integral of cosine 2x. The integral of x is x, and the integral of cosine 2x is sine 2x over 2. And that gives us, it's equal to x over 2 minus sine 2x over 4. Now, you have the notes anyway, but I'm going to not show you the answer here. And I'll ask you to integrate the integral, do the next one down here. I mean, you can look at the notes if you want to cheat or whatever, but not that it matters. Just basically go and do the same integration, but this time use this rule up here, yeah? And I'll pause this video here. So it's the second rule. So it's a half times the integral of 1 plus cosine of 2x dx. Now here I split them in two, but we can just do what we've been doing so far, which is to integrate directly. I'll use the square box. So the integral of 1 dx is x, and the integral of plus, and then it's the integral of cosine 2x. So it's sine 2x over 2 plus our constant of integration. So it's virtually the same as the other one. You just have a plus instead of a minus in that position. And that is what we have here in the notes down below. Okay. So everyone happy enough for that? You happy enough for that? Okay. So that's nice and easy. Now it gets a bit harder. But before we do that, I'm going to think up one here. And yeah, because we need to do it here, in fact, and I've room down here. So now I want you to do the integral, because there's a bit of a trick here. So it's 2x dx, and if you can go ahead and do the integral of this. And just figure out how you apply this rule up here to this particular problem. Yeah? You have to figure out how the tricky bit here is how do you apply this rule when you have a constant in front of here. So I'll give you a minute to have a go at that, and then I'll run through it. Well, you apply this follows. It's equal to a half times here. Do that in blue. Equal to a half times the integral of 1 plus cosine, and the deal here is whatever you have in here. So if I have 2 in here, I double it, so it becomes 4. So basically this doubles. Okay, and that's basically, and now it's handy. Now you just go ahead and integrate it. So it's equal to half times the open up a bracket. The integral of 1 times dx is x, and the integral of plus cosine 4x is sine 4x divided by 4 plus your constant of integration. Okay, so I'm going to ask you then to do this one. Sine squared 4x dx, sorry, I should have had a dx here, dx, and go ahead and give that one a go. So we're looking at this one. It's sine sine 4x to be squared, so that is equal to a half times the integral of 1, and it's the sine one, is the first rule up here, so it's minus cosine, and it was 4, so it has to be doubled, so it's now 8x like that dx. And then you're going ahead and integrating this, so it's a half times x minus, now the integral of cosine x is sine x, so it's sine of 8x divided by 8, like so, plus a constant of integration, so that's x over 2 minus the sine of 8x over 16 plus a constant of integration. So you just have to remember, you always double it. Whatever the coefficient of x is, gets doubled when you apply the rule. And then it's a standard integration after that. So if we come down then to these ones which are harder, but you need to know that rule. What do you do if you have sine to the power of sine x to the power of 4? So this is quite tricky, in fact, because what you have to do here is you have to split it into sine squared x multiplied by sine squared x, which is equal to sine squared x to be squared. Okay, and then when you've done that, you have to apply the rule that we had before. So we use the second rule, the first rule, sine squared x is 1 minus cosine 2x divided by 2, and you end up with this expression here, which you then multiply out. So you have to multiply out 1 minus cosine 2x times 1 minus cosine 2x, and if you multiply the, I'm going to do this in 2 different colors here to try and clarify the way it works. That's 1, that's cosine 2x. So when I multiply the top row by the 1, I get 1 minus cosine 2x. And when I multiply it by the bottom row, the cosine 2x, I go on to the next row, I get cosine 2x. I'm multiplying, sorry, by minus cosine 2x, so I get minus cosine 2x. And here, so, sorry, I'll go back a little bit. Here I'm multiplying the top row by the 1. So 1 times 1 gives me the 1. And 1 times minus cosine 2x gives you the minus cosine 2x. Then on the next row, I'm multiplying by the second term here, which is cosine 2x. So it's cosine 2x times 1. Sorry, it's minus cosine 2x. So I should say there's a minus there. So it's minus cosine 2x times 1. And now I'm multiplying minus cosine 2x by minus cosine 2x. So I get plus, because it's a minus times a minus, cosine squared 2x. Because I'm multiplying this by this, I end up getting a squared like that. And then that gives me 1 minus 2 times cosine 2x plus cosine squared 2x. So it's quite tricky because you're multiplying these ones together. And then, having done that, you then have to go around again and you have to substitute in this term here for that term there. And the idea is to get rid of all the powers and reduce them down to single terms. So there's quite a bit in this. So I'm kind of, what way will I do it? You can see the kind of way it works here, but if I had a blank page, I could do it on a blank page maybe. And that might be the best way to get it to work, just doing it on a completely blank page. So if I do a blank document here, A4, I'll make this say 10 pages. And we keep it, yeah, create document 10 pages here. So what we're looking at here is the integral of sine to the power of 4x dx. Okay, step number 1. Write it as the sine to the 4x as sine squared x times sine squared x. Write that as sine squared x to be squared dx. So is everyone happy enough? Step 1 is to split the into a square, basically. Okay, or reduce down to sine squared. Is everyone happy enough with that first step? Everyone's happy enough with that, yeah? Okay, so step number 1, your function is to the power of 4, so you split it into sine squared to b squared. Next thing we do is we apply our rule. So that is the integral, and we apply our rule inside the brackets. So is it 1 minus cosine? I have to remember this rule myself. Yeah, it's 1 minus 2 cosine 2x. So we apply the first rule in our table up above. So it's a half times 1 minus cosine 2x. So I put the 2 underneath because it's a half, and it's all that lot to be squared, yeah? Is everyone happy enough with what I've done there? I substituted in our rule in that place there. Is everyone happy enough with that? That I basically put a rule inside the brackets there. So just basically we've used this rule already. We used this rule when we were doing sine squared x. So all you do is you put that rule inside the brackets. You replace the sine squared x with 1 minus cosine 2x. The next thing you have to do is you have to multiply it out. So if I do it here, just like I've done before, 1 minus cosine 2x. This is 1 minus cosine 2x. So I'm trying to do it this way just to show you that when I'm multiplying the top row by the 1, I get 1 minus cosine 2x. And then when on the next row, I multiply the top row by the minus cosine 2x. And obviously, I'll put the minus cosine 2x in underneath the other one. And then this is minus cosine 2x multiplied by minus cosine 2x. So the minus times minus gives a plus. And we're basically squaring those, because I'm multiplying cosine 2x by cosine 2x. When I have this, then I have 1 minus 2 cosine of 2x plus cosine squared 2x. So I put that in down below. I substitute that into our equation up here. And remember, it's divided by 2 squared. Yeah? That's the top part I've squared out. So if I substitute that in now, across the top I have 1 minus 2 cosine 2x plus cosine squared 2x, and it's all over 4 because this 2 under here is squared as well. So is everyone happy with the way I squared it out? And then I just substituted in there. Is everyone okay with that bit? That I basically square it out, I multiply it out. So the 1 minus 2 cosine 2x when I square it out gives me 1 minus 2 times cosine 2x plus cosine squared 2x, and the 2 underneath becomes 4. I'm multiplying inside the brackets. Sorry, I'm squaring. Yeah, I'm multiplying everything. I'm squaring everything inside the bracket. So in effect, what I'm doing is, one. I have no room there. Sorry. I'll do it down here just to clarify that 1 minus cosine 2x over 2 multiplied by 1 minus cosine 2x over 2. That's what happens when you square it. You're multiplying it out. So I've done that multiplication up here. Is that okay? Is everyone happy enough with that? You happy enough with that, Brian? Yeah. Everyone okay with that explanation, yeah? That you're squaring it out basically. Okay, so then I'll copy this bit down here. I'll take this bit here. If I copy it, I don't have to. I think I can duplicate it. There it is. So I bring it down here, so I don't have to rewrite it. And then the only trouble is we still have our cosine here. We still have a power here. We still have the power of 2 here, and we can't integrate that. So what we have to do is apply our rule again. And this gives us, I'll bring the quarter outside. I think our life will be a lot easier if I bring that quarter outside. So it's 1 minus 2 cosine 2x plus cosine squared 2x. So all I've done in that step is to take the quarter outside. And then it gives us quarter times 1 minus 2 cosine 2x. And here now I have to apply this rule again. So it's the cosine squared, isn't that plus, I think, plus cosine. And it's 2 here, so that becomes 4x. So if I just do it here. Now this one is tricky. So it's a tricky calculation. It takes a bit of practice. So if you're looking at it now saying what the hell is happening here, don't be surprised. It's not easy. So it just takes a bit of practice and getting used to it. So if you look at it here, I've replaced the cosine. I've applied the rule again. So it's 1 plus cosine 4x in that case. And now what we've done is we've reduced this all down, that we now have the integral of 1 minus 2 cosine 2x plus a half. Just 1 times 1 is a half, plus cosine 4x over 2. So I'm just dividing these two, the half into these two, dx. And now what I'm able to do is integrate that. So is everyone okay before, sorry, I'm jumping ahead here. Is everyone okay with this step that I've done here? That we have to get rid of the square, so I have to apply the rule again, basically. So everyone see what I've done there? We can't integrate cosine squared x, so we have to replace it with a half times 1 plus cosine 4x. Did I apply that rule correctly? Is it plus a half in that case? Yeah, it is. It's plus cosine 4x in that case. So then, what we do then is we now are in a position to integrate this. So I put my quarter here. If you notice, I have 1 plus a half, so that's actually 3 over 2. So I'll just have 3 over 2. I'll tell you what, it's just more confusing than anything. I'll just integrate. So I get x there, minus 2. Now the integral of cosine 2x is sine 2x, so it's sine 2x over 2. So that is the integral of cosine 2x is sine 2x over 2. This one here is x over 2, a half x. And then this one here is the integral of cosine 4x is sine 4x. So it's already over 2. I have the 2 here, I bring it down. And then I divide by the coefficient of x. So if I do this, I have a quarter of my constant of integration. I have 3x over 2 because I'm adding x. I'm adding x over 2 to x, so I get 1.5 times x. This one is minus sine 2x because this cancels with that. And this one is plus the sine of 4x over 8. Plus your constant of integration. So let's be honest, that is a tough question. So you need to practice it. You know, you could tidy this up a bit, but let's just stop at that point. And is that what I got here? Yeah, I think that's, oh, you got 32. Oh, I divided across by the 4. I divided across by the 4, so if we come back out to my thing, come out to my solution, he's divided across by the 4. I've divided across by the 4 in the notes. So 4 times 2 is 8 minus sine 2x over 4. So I'm just dividing in by the 4 plus sine 4x over 32 plus the constant of integration. And I think that's the same answer we got there, wasn't it? If I just take it. I just check. Yeah, I think that's the same answer we got here. So now we're going to do cosine squared 4x, but I'm going to I have no room on this page because I wrote this stuff quite big. So we're going to do a step by step. So the integral of cosine to the power of 4 x times dx. So what's the first step you do? What's the first thing you rewrite that as? So just check the question. How is it 3x? Sorry, Luke. Yeah, where did I get 3x? Oh, okay, yeah. It's 3x because you have a half up here, yeah? And you have 1 here. So 1 plus a half is 3 over 2. So when you integrate this, you get x, and here you have x over 2. So when you add them together, you know, it's 1x, which is 2 over 2x, plus a half x, and that gives you 3x over 2. So it's 1.5 times x, so remember that 1.5 times is 3 over 2. So that's where the 3 is coming from. Okay, so step number 1 here. What do? Step number 1, you basically rewrite this as cosine x to be squared, like so, yeah? Okay. Step number 2 is give me a second here. I'm going to calculate cosine squared. What you do next? Do we calculate cosine x squared, or what do we do next? Substitute in. Really, what I should have said was substitute in. That's wrong, isn't it? So I wonder you're kind of saying, what am I saying? I should have actually said let cosine x to be squared equal to this. Yeah. So what I wrote there was rubbish. But the next step is this. What I should have said was let substitute in for cosine square x. So we know that that is equal to a half times 1 plus cosine 2x. Sorry, and I should put this over 2. Sorry, I should write it like this because we have to square it, yeah? So it's basically 1 plus cosine 2x. We have 1x here, so it becomes 2x over 2 squared dx, yeah? Is everyone happy enough with what I've done there? I've substituted in, basically, for up here, I substitute in for cosine squared x. I substitute in 1 plus cosine 2x over 2 like that, which is another version of that rule, basically, yeah? So that's what I've done here. I substitute that in. So the next thing we have to do is to square it out. So if I do that, 1 plus cosine 2x, and I'll do what I did before with the colour code, and that's the 1. That's the red I had in red, didn't I? Plus cosine 2x, and I'm multiplying this out. So the first row is 1 times 1 plus cosine 2x, so I multiply the top row by the 1. And then the second row, I multiply the top row by the plus cosine 2x, And of course I'm getting plus cosine squared 2x there. So we'll get 1 plus 2 times cosine 2x plus cosine squared 2x, like so. Okay, that's the top part, and I have 2 underneath. So what that gives me when I multiply it out is equal to the integral of 1 plus 2 cosine 2x. I'll do it actually. 1 plus 2 cosine 2x plus cosine squared 2x dx over 4. That's the 2 here is squared, so 2 squared is 4. And then I can take that quarter outside, so it gives me the integral of 1 plus 2 cosine 2x plus cosine squared 2x dx. So next step then is, it's tricky this, but it's just a series of steps. So my next step is to give me a second. I'm doing a poll here. Apply essential rule for cosine or integrator. So what do you do next? Now a lot of you are saying integrate it, but you can't integrate it yet. Okay, you can't integrate it yet because you can't integrate this until you get rid of the power. So the question is, how do you get rid of the power? Well, you say it's equal to a quarter times 1 plus 2 cosine 2x. And once again we apply our rule, so it's a half times 1 plus cosine. Now we had 2x here. If you bear with me here, I'll put it in green, we had 2x here. So of course here we're going to get 4x. And that is equal to a quarter times the integral of 1 plus 2 cosine 2x. And I just multiply this out, plus a half, plus cosine 4x over 2, because I'm dividing across by the 2. And now these are in a position where you can integrate. Before I integrate, I'll just do half, and I'll add the 1 and the half together. So it's the integral, before I integrate, I can add these two together. So it's 3 over 2 plus 2 cosine 2x plus cosine 4x over 2 dx. And then the next step is to go ahead and integrate. So it's equal to a quarter. Open up a bracket. It's 3 over 2 times x. It's a constant. Plus 2 times, and the integral of cosine 2x is sine 2x, and you divide by the coefficient, which is the 2. And here it's cosine 4x. Now we already have a 2 underneath. Sorry, I did that wrong. We already have the 2 underneath, so I can say it's a half. And then it's the integral of cosine 4x is sine 4x divided by 4. Plus a constant of integration. So if we then bring this down here, divide across by the quarter, so 4 times 2 is 8, so it's 3/8x. That 2 cancels with that 2, so it's plus sine of 2x, but I'm dividing across by the 4. And here I have 4 times 2 times 2, so 4 2s are 8 and 4 2s are 32. So the 32 here is coming from 4 by 2 by 4. We have sine 4x over on top. So it's much the same as the other one, it's just pluses instead of minuses.
And where did you get the first two from?
Hang on. Yeah, that's the same as the other one, but you have a plus. You have a minus up here. I'm going to come Tematope and answer that in a second. You have a minus here, and here you have a plus. Otherwise, it's identical. It's the same. Sorry, which 2 were you talking about? This one here?
Cos 42.
Cos 4x over 2. Yeah, basically, when you applied the rule here, it's a half. See the half here? A half times 1 plus cosine 4x. So I bring that 2 underneath, and that's where the 2 is coming from. Because from the rule, it's a half times 1 plus cosine 4x. So that's where the 2 here comes from here. And then when I integrate it, it's the integral of cosine 4x is sine 4x over 4. So the 2 stays there. But remember, we have a 4 out here as well. So when we get in the 32 here, it's the 4 out here, multiplied by the 2 that was already here, multiplied by the 4 when you integrate the sine 4x. And that's how you're getting your 32. Okay, these are tough questions, but they do come up, and both of them come up here. This and the next one, obviously I'm not doing the next one today. We'll do this on Friday. We'll do the odd powers on the Friday, but you use a different rule for the odd powers. But this is where it's equal to, this is for the sine function, and this is for the cosine function. But you can see that, you know, when you go and look at them in the exam, they normally be definite integrals, and it could be cosine 4x, and it could be 2x like that. And you might be going from pi to 0. So a typical exam question would be a bit more tricky than that. So you really have to practice these and give them a go and practice them. We'll be doing more on Friday, and we'll be doing the odd powers as well. Okay. Okay, it's quite tricky, but it is a procedure. You're just going through a procedure.